Our next presenter comes from one of the Edge AI and Vision Innovation Award winning companies this year for its IP. The company name is Quadric. With us today is Nigel Drego, co-founder and chief technology officer. And the title of the presentation is ONNX in Python to C++, state-of-the-art graph compilation. So come on up.
Thank you. So let me get started here. I'm gonna just talk a little bit about Quadric to begin with. We're an 8-year-old startup. We are a pure play semiconductor IP licensing company. So we license processor IP and the software tools that are around that processor IP. We specialize in edge and device applications, machine learning, AI, as well as DSP processing. As you'll see, the architecture is more than capable of DSP processing and really any data parallel processing. We're headquartered just up the road in Burlingame, and we have proven this out on silicon and delivered IP to multiple customers. So I want to get started. Before getting into any of the graph compilation, I want to talk about the architecture itself, because at the end of the day, the graph compiler and the architecture are one and the same. You can't really have one without the other. We call this architecture a Chimera general purpose NPU. And the reason we call it Chimera is because in biology, that's a hybrid of 2 DNA streams. And this architecture is really a hybrid between a CPU and a systolic array. Just like all other NPUs out there, including the one we just heard about, we start with max and local register memory, SRAM. But unlike most of our competitors, within a processing element, we include a 32-bit ALU, which is a full C++ target. That processing element is controlled by an instruction, proprietary ISA, 64-bit instruction that encodes both data movement and compute simultaneously. So this processing element is essentially 4 stages of a 7-stage processor pipeline. We give this processing element access to its direct neighbors as well as DMA engines. We tile all of these things out into a 2D array, and that becomes the architecture. Okay? DMA engines give it access to L2 memory and external DMA engine out to external memory that we're agnostic to. Could be HBM, DDR, whatever on-chip SRAM you may have, etc. And as you can see, there's a single instruction fetch pipeline for the entirety of the array of processing elements. This entire thing is scalable all the way from 1 to 864 tops and beyond.